Guys, now,
What are you doing?
slides.
Wait, what are you doing here in the November? What are you doing?
I'm also a researcher. I do the research on neuroscience.
Oh, that's fun.
Guys, now let's get started. Today I assure you this. Oh my God, class feels today different.
I know, I'm kind of glad.
It seems more spacious.
It feels great though.
Yeah.
Why is there one desk with?
Now,
Less like that.
guys, today we are gonna start with the part of the functions. Essentially, when you finish level 3, it is expected that you know 5 types of the functions. We learned 4 of them yesterday. We talked about the linears, we talked about the square root function, we talked about the rational expression. Today we are going to learn about a function which is actually my favorite. Why?
Oh, the line one.
That's right.
Linear function.
We call that. For example, yesterday also we worked on only with one single expression, Matthew, and that was this, 4x plus 12. We did it once, we just find the domain of this function, Ella as the way it is. Then we saw then we just put it, we reciprocated, then we had 1 over 4x plus 12. Then we thought that it's raining, we put it under the umbrella, and we just looked at them. We then learned, I showed you a magic tree, I showed you how to just put a fish into a shark, then that's what we did yesterday. Now, we are not going to just work with the fish or shark anymore. Imagine that before we are going to on November the break, we are working, we are gonna just have some fun with something which I call this. Everything's fine.
Yeah, sorry, it's a crack in it. I keep like pinching my skin.
No worries.
Yeah,
Yeah.
kind of.
I put this function now, before we just put it under the umbrella, now I just put it inside 2 parallel lines, and we are just gonna work with this function.
What's that called?
This is called absolute value function. I'm just going to write this like this. I say that, imagine, before I just go over there to solve that problem, guys, please take so much attention to these type of functions, because when you go to level 5, when you study the calculus, you see that this function over there is going to cause so much trouble. Now, then, as a result, learn it right now, that when you just move along, you should see that, okay, life is going to be very easy. Look at this. This function is essentially a type of the functions that we show this like that. Let me, before x, I put it something like an apple. I always start to put the apple inside the function. Then you go to the walnut. Now look at this. If you have a function which is something like this, the f of x,
F of apple.
that's right, f of apple, it gives you something like that. It says that you put the apple inside 2 parallel lines. They call that absolute value function. But what does it mean? It means that you have 2 chances, 2 options. Whenever you see this, you have to look at this. As I was saying that to one of my classes during the summer, I said that whenever you see this symbol, it's as if you are going for your November the break. Somebody just wants to just treat you with something nice, give you a bag of nuts. Then you pick up a walnut. You pick up a walnut and you see that, oh, I cannot just have the walnut because it has a hard shell. Then what do you do?
What is this mythology?
Is
Makes
it?
perfect sense.
Okay. Elisa, listen. Then what do? When you have the walnut, you have to just look at this. You just pick up a hammer. Elisa, you're being important.
Sorry, that was not even funny.
I'm sorry, just how are we going to apple to the hammer?
Yeah, look at this. And now that's the funny thing. You're going to remember it for the rest of your life. When you look at this as a walnut, you have to break it. Huh? Because you cannot have it as, I should say, with the hard shell. When you use the hammer to break it, it gives you two options. Either you take the core, look at this as a walnut, not the apple. I'm so bad you just dry the walnut. Look at this as a walnut, for example. Now, you have two options. Either when you break it, you pick up the core of the walnut, keep it there, or you take that walnut and you put the minus sign before it.
No more walnuts.
How?
So you just put a message.
That's right.
So you
And now, listen. And now, when that thing is happening, is that you have two options. Then now, if you were, guys, please now be serious. It's not about the walnuts, apple, listen. Behave. Now, look at this. So, and now, if I say that f of x now is not the absolute value of the x, the thing that we do is this. We say that we cannot work with this function at all unless we pick up the hammer and break the shell of the walnut and to take this out the core inside.
So minus x.
And we said that either you have the x inside, but it comes with the condition that if x is positive or equal to 0. We learned that yesterday, that when we have this symbol, means x is greater than 0, or it's equal than 0. It's either is greater, it means that if you are looking at it along the x-axis, and that's the 0, we were able to visualize yesterday. We said that, okay, you start at the 0. We know that the x is going to get bigger and bigger. Then it means that when you're standing at the 0, you have to face in the right direction. Then it means that anything along that, it just counted for this. Now, but however, if you're facing that way, then that is, I have to feel this because I said that it's also equal. But it's also, there is an option that you are moving along that direction. X is negative. Then in that case, the function, when you take this out of the core of that shell of the walnut, you just put one minus there, you say minus x. This is for the case that x is negative.
We've never seen that.
That's the first one, that's right. This is the first one you're going to learn this. Yes.
So if x is positive, wait, x is bigger or equal to 0, but when the negative is only just like it's smaller?
That's right. And the purpose is that, guys, the purpose is that they said that the absolute value function. Why they say that? Because look at that. The output from that function, it is always going to be positive. You say that, okay, if x is positive, I remove this out. Look at this, I didn't change anything. I only took out those hard shells surrounding the x. Then the purpose of the absolute value function at this symbol is that to give you an output which is positive. Look at this. For example, look at this drawing which I'm going to have. It's going to be the function which is absolute value of the x. You have an input and you have an output. Because that's what we talked about in functions. We have input, we have output. The purpose of this function is this. You give something to this, it spit it out positive. For example, I give, for example, plus 3. Plus 3 goes inside the function. What do I have outside?
Negative.
Plus 3.
Plus 3, yeah.
That's right. Because the purpose of this is that anything you feed to the machine, it gives you it as positive. It doesn't change it. It doesn't subtract anything from it. It doesn't multiply that to anything. Nothing. Just make it positive and send it out. Now, imagine that if I send something like that, I put minus 4 as an input to that function. What is the output?
Minus 4.
I send something minus, goes inside, it becomes positive.
What?
It becomes plus 4.
Is it always positive?
It makes everything positive.
Wait, what if you have positive input and the output also just be positive?
That's right. Positive 3,
Oh, yeah.
the output becomes positive 3. Minus 4, the output is plus 4.
So how can you get a negative output?
Never.
Yeah.
The output of the absolute value is always positive.
How do you
Never.
get a minus x then?
Oh, I'm going to tell you. Why? Because look at that. Elisa, look at this. We say that if the input, which is x, is something as a minus, yes, Jeff.
What would a question be like on the test for this?
I'm gonna show you. Look at this. We have a minus. We say that if something is minus as the x, we say x is minus, negative. Then you add minus to that. Becomes our x is minus 4.
Mm-hmm.
Then we put minus here as what was did. Then minus minus 4 becomes how much? Plus 4.
Oh.
Now that's
I have
that.
a question.
Yes.
Yeah, how come when you put minus there, you put x is smaller than 0?
Yeah, I said that if x is less than 0, it means that where we are, at the area that all the numbers are negative. Then if the numbers are all negative, you put it into this function, you multiply by minus to make it positive.
So it's a few.
That's right. Look at this. This minus sign is a tool that you can make every negative number positive. But if the number is positive itself, we do not bother with this. We just take it as fine as positive. Does it make sense, everyone?
Yeah.
Now, the thing is this. Before I just solve this problem for you, we only do this today. We are going to take today so easy. Then we only just talk about this function.
But what if? Oh.
Yes, what if? It's a good question. Anything that starts with what if, it's a good question. What if?
Since you did it's minus 4 because the x is negative, so you put a minus in front of it. What if it was minus? What if x was minus for the plus 3?
Minus plus 3?
Like.
If the number is plus 3, you keep it plus 3. Because the only thing you have to concern yourself with the absolute value function is that anything goes inside comes positive outside. Yes.
Wait, what is this called?
Absolute value function.
What if the absolute value function was negative x?
Becomes positive x.
No,
Negative
what
x.
if the function was fx equals the 2 bars, and then there's a minus x in the middle, except for instead of an x?
Okay, look at this. If it was, let me first of all write give me this one, Lucas, huh?
Yeah,
I'm
exactly.
going to tell you. Look at this. That is called absolute value functions. In the handout, which I gave you yesterday, you have the second part of it. It comes with that function.
All right.
And look at this, Lucas. This is a very good question. It says that, what is this function?
Minus x.
We say that, okay, if this is minus x, it means that if x is positive, look at this, it's a very interesting question. You say that if x is positive, always that's what we do. We say that if x is positive, then minus x, it gives minus something positive, which is what? Which is a minus. For example, f is positive is like plus 3. You put it inside the function, becomes absolute value of minus 3. What is the purpose? The purpose is that to take this out as positive, then it becomes plus 3. That means that you have to put minus there.
But what if plus 3 went in the minus x? Then isn't it minus 3?
Yeah, it becomes minus 3 inside. In the stomach of this function, there is something minus. Then it spit it out as positive.
But
Then
even
you-
if the plus 3 goes in the minus x?
If the plus 3 goes inside,
Yeah.
it becomes minus plus 3. It becomes minus 3.
So
Yeah,
it's
you're
minus-
minus 3. So
Minus 3.
You do get a negative number.
No, but when it comes outside, you learn it has to always be positive.
So it's minus plus 3, but then you don't write minus, you just write minus on the outside bracket plus 3.
Look at this.
So can you do what you did there? You put plus 3, then you got plus 3 out. So if you put plus 3 in there, what do you get?
Plus 3 inside the function.
No, you see how you wrote plus 3 as an input, and then you get plus 3 as so what do you get there if you put plus 3 as an input?
Plus, look at this. That's what it is. Plus 3 is in this range, huh? X positive.
Yeah.
If this is x positive, look at this. When you put it inside, when this function is follows that, it becomes something like that. Minus 3, correct?
Right.
But the problem is that we know that anything which goes under the stomach of this function, it is split out to be positive. Then I know that it has to be plus 3 when it goes outside.
So there's no rules. It's just positive.
Everything comes positive.
So you don't really need the negative x in there.
When it's negative x, it means that you change the rules that you said. It's going to be a little bit flipped. Then when the x is positive, now I'm just going to solve this example for you, and it's going to make total sense. No worries. Now, when the first time I saw that function, it didn't make sense to me. What does it mean? Everything has to be just going out positive. Now, look at this. I'm gonna, first of all, before I continue, I'm just gonna plot this function. Let me write this. I say f of x equals to absolute value of x. If x is positive, we have plus x. If x is negative, we have minus x. Now, guys, look at this. It is a very important plot that you're going to see in the whole functions course that you're going to have this year.
Is this functions grade 11?
Yeah.
That's right. Look at this. Everyone can see this at the back? This is the x-axis, this is the y-axis, and that's the origin. Now, guys, what is the task? This task here is that I'm just going to plot this function. But before plotting this type of function, I'm going to remind you of something. You remember when we talked about the linear functions, we had, for example, this is the x-axis, this is the y-axis, and they are intersecting perpendicularly. We talked that if we have a function, for example, y equals to x, it was easy to plot this. We said that, okay, we take this one, it is y equals to x. We have no problem, huh? And at the same time, I was able to plot another function, y equals to minus x. Close the door. Now, look at this now. Guys, everyone focus. Now, I had no problem before to plot these two functions, y equals to x and y equals minus x. Now, I'm going to plot this function, and now look at this, how the interval is going to distort these functions which I have. I say that, everyone please eyes on the board, it is a very important part. I say that if, look at that, I say absolute value of the x is not one function, it's like this. It's the human body, look at this. This is a neck, these are 2 feet, and these are the shoes, these are the hands, these are the hands, this is the neck, one head there and one head there. It is a function with 2 heads. Yes, Matthew?
Can I follow up, please?
Yes, yes, sure. Now, when I look at this function, it reminds me of something like this. A human body, yes.
So the absolute value function is like the two parts of the other function, like y minus x and y plus x are positive.
That's right, but we have to segmentalize it. You're right. That's very good, yes, Ella. Thank you. And now, when I look at this, as Ella said, I said, okay, with this function, which it has 2 heads, I have to draw 2 different pieces. That's why they call this piecewise functions. For the first part, I look at this. The first head, this is the human body, this is the first head. It says that, guys, look at this is very important when we have intervals, how to interpret them. I say that when x is positive, and this is not only for this problem, you are going to see this over and over again in the same conditions. We say that if x is positive, it means what? X is positive is this direction, huh?
Yes.
On the right side of the y-axis, all the x's on these 2 quadrants, quadrant 1 and quadrant 4, all of yes.
Since sorry, you can finish that. So you're saying how so their x is greater than or equal to 0? So when we say that f goes through, it's on 0 and it starts from 0 and goes all the way positively.
That's right. It means that anywhere you are going to be here, Lucas, either quadrant 1 or quadrant 4, x is positive, then the function head is represented by, for example, plus x.
Okay, so the y value doesn't matter here, just the x value.
That's right, just only the y value. Look at this. The function is this. Look at this. Imagine the second head doesn't exist. It means f of x equals to plus x. And that's what I did. However, it puts the condition that x has to be net positive in order to have this. X positive is on the right side of the x-axis. Then as a result, it means that I have to erase the lower part of the y equals to x. Because on the other side, x, look at this, x is going to be negative. That's right, Elisa. Awesome. It's the first part. Now I dealt with the first head of the function. Now, I'm going to go to introduce myself to the second head of the function. The second head is minus x. What does it mean? I'm going to draw the second part of the graph. Let me do this with a different color. This is y equals to minus x. But it tells me a condition. Simon, the condition says that if x is negative, you plot minus x. Where x is negative? X is all negative on the left side of the y-axis, which means that the right side of the red plot is going to be useless because it does not satisfy this part. Then as a result, I'm just going to erase them. I'm going to forget that I had this part of the graph. Then as a result, we can say that. Let me do this and do this. Then as a result, I say that this is the plot of the function y equals to absolute value of x. And as you can guess, there is the angle between them. The angle between them is going to be 90. They are perpendicular to each other. This is going to be the plot of absolute value of x. And I hope that you get and you learned how to incorporate these conditions when it comes to plot a function. Yes, Lucas? Awesome. No worries.
Wait, so the angle
Is 90. Means that they are normal to each other. Y equals to minus x, y equals to x, they are perpendicular. But based on the different conditions, each line, you just put only one part. Makes sense, Daphne?
Yeah.
Awesome. Thank you. Yes, sir. Yes, please. Now, let me erase this, otherwise people see that, oh, what do they do in the class? Now,
Mr. Daniel?
yes.
So we're going to have to draw the function in the test. If you say draw the function of y equals absolute value x,
That's right.
it won't always, it'll always be that.
Just for this, it's always that. Because you say what? Because you say that if I look at this one, I say, oh, the absolute value, it reminds me of the walnut. I'm going to have the core, but I have to break the shell, Janaya. I break the shell by the hammer, then I have two pieces. Look at this. This is a walnut. It just breaks when you use the hammer. The first half, the second half. And now you see that only this function takes that format. I'm going to just use this strategy over this function.
Yeah, so it would be the same thing, but it would be an intercept. So 12, it would start at 12, go up by 4.
Fantastic, fantastic, Lucas. Brilliant.
Oh man, I swear I was the first one.
Mr. Daniel, what is the called when you write plus? What is it called? Is it like a domain again?
Which one? Here?
The ones in the big one. Yeah.
This one?
No, before.
Absolute value.
No, the ones, the things inside that.
In this one? This is the function itself. And this is still this, but it's broken. That's why generally they call that piecewise function. Because there is one function, but it gets two heads. One human body with two heads. But this is still the function.
What about, are there ones with three heads?
We are gonna have it in future. It becomes like a dragon. It is indeed.
I'd like to see this. I'd like to see it.
Guys, now,
He's still there?
guys, now I'm just gonna solve this problem for you. Then you should be on your own to do some exercise.
I didn't know. Yeah,
Where did he go? Downstairs.
He's probably I want to mustard.
It's like y equals.
I was like to say that it's so Trevor.
Y equals 7x, you plot. It becomes plus 7x there, minus 7x here, but the plus becomes y equals 7x, y equals minus 7x. And it's going to be like that.
But how do you draw this?
Seven x and x, the slope, they are again perpendicular, but 7x has a higher slope. It approaches more to the x-axis. You know? But I'm just going to solve this one, and you're going to get the answer. Because this one is more challenging than the other one. Now, guys, let's deal with this. The problem which I initially started the session with.
I have a question.
Yes, please.
What are the two lines?
Means the true line, absolute value.
Oh,
Means, for example, it means that I'm going to read this function. Means that f of x is absolute value of 4x plus 12.
what's absolute value?
Absolute value, it means that you get the value absolutely positive. It stands for that. It has to be always positive.
Oh,
Anything comes inside these two perpendicular lines has to come outside as positive. Good questions. Now, I just want to solve this. I say f of x, and I plot it over there. Absolute value of 4x plus 12. Now, for example, you are walking and somebody throws you this function, and you say, okay, now I have to solve it. It means that now, guys, do you remember that when I showed this, I said that anything comes inside. Let me just put the general formula here. Not doing the apple or walnut.
It's right there. It's right there.
That's right. No, even more general than that.
What's that?
I downloaded it.
You can't make one and a few things, but
Matthew, look at this.
Matthew, come on.
If you have a general term, f of x, inside the function, absolute value, you say that f of x can come outside by itself if f of x is positive, or it can come with the minus behind it if f of x is a negative function. That's what we expect. If something is negative inside, we multiply it to the minus to make it positive. Now, I'm going to do the same.
Isn't it greater than or equal to 0?
That's right. Oh, yes. Thank you. Now, look at this. You have only 2 minutes to finish the lesson today, and you should be on your own.
we're done in 2 minutes.
That's right. You solving this one, then you just go to your handout.
they were done like half an hour.
Guys, look at this. I look at this function, and I see I have those two perpendicular lines, which is the sign of the absolute value function. I've identified the core which is inside. The core inside the shell of the walnut is 4x plus 12. Then what do? I'm just going to break the shell, have two pieces of this. First of all, I know that I can take the full function outside. Look at this. For example, for this case, I took the full function outside without changing it. That's what I'm going to do. Then the first head on the human body is going to be what? Is going to be 4x plus 12. I do not change it at all. However, my friends, what is a condition to do that? Is that your f of x, the 4, that you took it outside becomes all positive. Yes, Elisa?
Yes.
Which means that I'm going to write it by red, which means that 4x plus 12 has to be greater or equal than 0. Yes?
Yeah.
On the other hand, you know that you can take this out, but you have to put the minus sign out there. You say minus 4x plus 12. And now, I know the condition for it. I know that the only way, Lucas, the only time that I can take this out is that the f of x itself is negative, then I put one negative sign behind it and I take this out. And it means that then as a result, 4x plus 12 here should be negative. I know. Now we come back to the thing that we discovered yesterday. You take a look back, you see, oh, look at this. I have 4 times of something plus the plus something has to be greater than 0. What is that thing? And I tell you, my friends, that's again the linear inequalities that we learned yesterday. And we saw how a fish can turn into a shark. Now, then as a result, I'm going to continue. I continue with the conditions. What is the condition here? The condition is this, that 4x plus 12 should be positive. And Daniel, how about the x? In order to find the x, what do I say? I say that, okay, I take 12 to the other side, then I have 4x is greater or equal than minus 12. That's exactly what we learned yesterday. I'm going to, yes, ma'am.
When you do greater or equal, shouldn't it be like the greater than right under it?
You mean this one?
Yeah, like the.
That's on the, yeah. That's, it means greater or equal.
Okay.
Now, the strategy was to isolate the x, which means that I'm going to divide both sides by the coefficient of the x in order to isolate it. Then if I divide both sides by 4, I do not use the trick to change the fish into a shark, because that's a positive number. Then it means that x is greater or equal than what? Minus 3. Let me put a circle around it, because this is very important. Guys, every eye is on the board, please. Then what does it mean? Ella and everyone. Look at this. What does it mean so far? It means that I give you a function in the absolute value notation. You say that I can take this outside as the first head on a human body to be positive output, but you said that the condition is 4x plus 12 being positive itself. You solve this linear inequality, and you get to this point that x greater if x is greater than or equal to minus 3, which it means that only and only if x is greater than minus 3, you can take the function outside as a first head on that human body. And that's the thing which you can connect it to this. Now, you say, Sandra, you say, Sabrina, I'm the fourth person in the whole world when it comes to this.
It's okay, you have a lot of classes.
Oh, yeah. Thanks for understanding. Now, I look at the second one, the second condition. You step back, you say, oh my God, look at this. This is another linear inequality. I'm going to solve it. Then how to solve it? The strategy is always to isolate x on the left side. I keep 4x to the left. I take 12 to the other side, it becomes minus 12. And I divide both sides by a positive number, which means that I do not change the direction of the inequality. Then I get x is less than minus 3. Which it means that this function can constitute the second head on that human body coming outside with the negative sign only and only if x is less than minus 3. Yes?
Makes sense.
Isn't that beautiful?
It is.
Very true.
So true. Oh, thanks for reminding me of that expression because I forgot it myself. I haven't used that for a very long time now. I promise after November the break I'll come with that. Yes.
Wouldn't it be minus 4
No, we do not do that. We keep minus 4x plus 12 there. We do not change it. But we work on the condition.
That's fine.
It's the one which is written on blue, it remains there. But I work on the red one, which is the condition.
$20 for the no
For
worries.
the equal.
But Mr.
Yes.
Not that yet.
You got a negative number and it's also not
Negative number is the condition,
I found that okay.
not the function itself. Which it reminds me, Lisa, I rewrite the function again.
That's a good question.
Yes?
Look at this. Now, guys, I'm going to rewrite the function before plotting it. Then we said that f of x, the function, has absolute value of 4x plus 12. It's essentially gets two heads on one human body. The first is 4x plus 12. If and only if I put semicolon, which it shows that there is a condition. X is what? Greater or equal than minus 3. Yes?
So how do you solve it after finding these two heads? Like, do you rewrite?
No, we do not solve it. We simplify this by this. It means that this function is not the function itself. We check this outside to simplify this.
So that's like on a test, for example, if you give a function like that, that's all you have to show.
Like the one which we had in the summer, it becomes an equation which involves that term. Now we have just simply a function, but we do not solve it. We do not look for the heading. And now, and also, it becomes minus 4x plus 12. The second head on that human body, if and only if I put a semicolon, that x is less than minus 3.
Okay with the final answer?
That's right. That's the final answer.
Makes perfect sense. This is the range.
And now, these are the domains of the function. You are not the range. I'm not talking about the range in 1 second. Then guys, Elisa, look at this. The minus 3 means that if x is, guys, look at this. What does it mean? Choose a number before I plotted it. Choose a number which is greater than minus 3.
Minus 2.
Minus 2. Put minus 2 here.
Your minus 8 plus 12 is 4.
Minus 8
4.
plus
You see the number is positive, then that's why we took it outside the way it is. Now you choose a number less than minus 3. Minus 7.
Minus 8.
Minus 8.
Yeah.
Minus 8 times 4 becomes how much?
32.
Plus 12. Minus 20. Then you have a minus before
Positive
that.
20.
Minus 20, which is positive, and that's what we are looking for. Any x which goes inside and turn it to be a negative one is killed. Well, and now it becomes a positive number. Oh, that was a very strong word.
Exactly.
Why do we discriminate?
They're destroyed.
Because you are looking just for the positive. You are not looking for the negative people. You say the positive people are more welcome, and that's what that function does. There is no negativity. Everybody has to be a positive person. No negativity. Everyone has to be positive.
I'm
So.
positive.
Now, guys, now look at this. Let me see if that angle is perfect. I'm gonna erase this part. Now let me erase this in order to plot it. When I do the plotting, please listen. How do we segmentalize, I should say, different parts of the graph? First of all, I want to plot this function. What do I do? First of all, I need a Cartesian frame which provides a reference. For example, that's the x-axis, that's the y-axis, and they have the origin normal to each other. Now, look at this. I'm looking for this critical point. X is minus 3. What is x minus 3? It's here, for example. It becomes like the boundary for me. Now, I say that if x is greater than minus 3, means which side of the minus 3? If x, look at this, along the x-axis, if you walk towards the right, x are getting bigger, bigger, and bigger. If you walk towards the left, x are decreasing. Then when you're looking for x greater than minus 3, it means that you are looking for the numbers which are getting bigger. Means that this right side you have to walk. Then x greater than minus 3 is for the x's on the right side of minus 3. It says that if x is greater than minus 3, the function is 4x plus 12. What is 4x plus 12? We know that 12 is what? Is the y-intercept, where we cut the y-axis. Then if I want to plot it, you say that, okay, it's 12, for example, here. Let me bring it a little down. For example, 12 is here. I'm going to draw this line. This is 4x plus 12. 12 is the y-intercept. It means that it crosses the y-axis at 12. And the 4, which is the slope, it means that it's going towards the y-axis. Now, this is this one. Guys, but look at this. We said that if x is greater than minus 3, we are looking for this function. Then if x less than minus 3, which is on the left side of the minus 3, then it's like a garbage for us. We have to put this into the garbage bin. Then how to put this into the garbage bin? After minus 3, I'm going to erase it. Right? Isn't that cool?
Yeah.
Now, the next piece, it says that if x, look at this, always we focus on the conditions in red to find the area interval on the x before we do something. I say if x is less than minus 3, I know that if I'm standing at minus 3, if I head that direction, I'm going to the smaller edge. Yes?
How do you know how to plot the line? Because we didn't have to have to do the 4x. You just draw a line.
Not just approximately. I just approximately because 4x is parallel to the y equals to x, and the intercept is 12, I simply divide it like that.
So any line that goes by 12 is okay.
If they have their slope as 4,
But what if it didn't have the slope?
if it was, for example, 5, it has a higher slope, it approaches a little bit towards the y. The angle becomes different. But you have had to listen at how to draw a linear function, huh?
Like a long time ago.
Oh, no worries. But for example, if you want, you pick up 2 lines, 2 numbers, then connect them. I just did it approximately. But if you want to do that, take 2 numbers from there. For example, put once x equal to 0, you get y equals to 12. The 1 point is there. Take x equal to 1, you get y equals to 16. For example, 1 and 16 there, then you connect all those 2 points together. No problem. And also the other one, x is less than minus 3. it becomes what? Minus 4x minus 12. It means that, for example, if this is minus 12 as a y-intercept, my line is going to be this. This is what? This is minus 4x. I take minus L now inside, minus 4x minus 12. But I say that if x is less than minus 3, I have to draw this. Means that this side x is less than minus 3. Then I bring my garbage bin. I put these parts, which is on the right side of minus 3, to the garbage. Then now, you see that this is going to be the plot for this function. The whole point was that to show you how to just work with these intervals.
Do you write minus, then what do you write? Minus 5?
That's right, minus 4x minus 12. And that becomes the way that we plot it. Now,
It's not, oh.
no, everything we have to take care of it. What's the question?
Is it minus 12 because you just doing the minus?
Minus 1x minus, that's right, minus 4x minus 12. Awesome. Now, any questions, guys? If no, let's take a minute break. Yes.
When is it minus 4x minus 5? Can you just write the minus and the 4x plus 12?
Oh, there is no break like that. I mean, guys, there is no break yet. Please take back your seats. There is no break. Sorry. Yes.
Can you just put the minus outside the parentheses 4x plus 12 next to the line instead of minus 4x minus 12?
Yes, still we can do that. I wanted to show that we can also distribute it, but if we don't want, yeah, we said minus 4x plus 12, but inside the line.
So you don't have to expand it, right?
Yes, you can just keep it there.
Thank you.
No problem. Yeah.
Like my dad.
Okay. Guys, now please go to your handout.
This is gonna sell, trust me.
You're not going to be laughing when I'm sitting on top about $100,000.
You people increase in the mental freedom, right?
James.
James, bro, get away.
Okay, now, guys, please go back to your handout. In your handout, you see that the last question on page 2, we have this one to solve this inequality. 2x plus 2 is less than 8. Okay.
We didn't learn that.
We're going to talk about it now. Now, guys, we have only 10 minutes, and we have to make the best of the time, because that problem, we are just going to solve it. I'm going to make sure that we solve it before we leave. Then please, listen very carefully, and you please at home rework on it and try to reproduce the same thing. Because unfortunately, I have to solve it myself right away. First of all, guys, look at this. For just 1 minute, imagine that this equation which I have here, there is not an inequality. Imagine that I have 2x plus 2 as a function. Imagine there is not inequality yet. Because we cannot do the things that we learned yesterday. For example, you may have to ask yourself, okay, the strategy is this, to just take x isolated, I take 2 to the other side, divided by 2. Can I do that?
No, you
Of course. There is a hard shell. You have to break it first. How to break it? I say, okay, now I bring my hammer, and I say that I take 2x plus 2 outside without changing anything. If I do this, I know that the only thing which I can do is that 2x plus 2 has to be a positive number or equal to 0. I know that this is the only condition which allows me to take whatever is inside the hard shell to take it outside, if that thing itself is a positive number. Otherwise, the second option is that I can just put it with a minus. I get 2x plus 2. Only I put semicolon that 2x plus 2 is a negative number. That's what I do. That's what you learn. We take it directly outside. If this is positive, we switch it with the minus if that is negative. Now, I'm gonna just work on these conditions because I take a step back and I notice that these conditions are linear inequalities. Then it means that 2x plus 2 is greater than 2, greater than 0. I take 2 to the other side, becomes 2x greater than minus 2. Divide everything by 2. That's right, x is greater or equal than minus 1. That's going to be my first
Why do you
condition.
want to do that?
Because we have to solve this inequality.
But we didn't do it for that one.
We did it.
No, we did.
We did it. And that's the end result from them.
Oh.
Look at this, Elisa.
Oh,
Inequality,
sorry, yeah.
I give you inequality, you solve it. Now, close your eyes, solve it.
I get it.
Awesome. Now,
Easy.
the other thing, I just 2x over here is less than minus 2. And x is less than minus 1. Daniel and Lucas. That's it. Now, I have these two things. I haven't yet looked at the inequality. I look at this one then now. I say that absolute value of 2x plus 2 then is like this function. It becomes 2x plus 2 if and only if x is greater than minus 1, or minus 2x plus 2 if and only if it's less than minus 1. But guys, within the short time that we have, look at this. We initially started to solve this. We said that we just want to solve this absolute value as an inequality, Lisa. Then it means that I have to introduce 8 to this. Then it means what? Still, I keep this. Look at this. The condition is that x is greater or equal to minus 1. X is less than minus 1. I know that it's less than 8. Then I know that each one should be less than 8. It means that I say this one is less than 8. And also this one should be less than 8.
Why?
Because I know that this is inequality. And it says that it's less than 8. Then it means that each head of that human body should be less than 8. Now guys, look at this. It is easy to solve it. How to solve this? I take 2 to the other side. Becomes 2x is less than 6. And I divide by 2. X is less than 3. I know that if x is greater than minus 1, the first inequality x is to be less than 3. Guys, look at this. This is very, very important. I have 0 here on the x-axis. I show this one, x greater than what?
But
Minus
are we going
1.
to solve the second one?
Sorry, what?
Are we going to solve the second one?
That's right. X is less than minus 1 here. And I know that the x is greater than this. X has to be this. But when I solve it, it says that x is less than 3. If this is 3,
Oh.
x has to be less than 3. It comes there. You see that the thing which is overlapping is going to be the answer.
Okay. So x is greater than 1 but less than 3.
That's right. X is less than
Can you
3.
do the second one just really quickly before the
That's right.
The second one you do minus 2x minus 2 is less than 8. Minus 2x is less than 10.
Oh, sorry.
10, yeah.
Yeah.
And then x equals 10 divided by minus 2x. So we have to flip, yeah, and then yeah.
That's right. This one, and I do the same thing. The x-axis, I have 0.
Perfect sense.
X less than minus 10. First condition is that x is less than minus 1. it means that this is, they are all x's less than minus 1. How much time do we have?
Oh, 4 minutes.
2 minutes.
And x is less than minus 5. This is this number.
Okay, that makes sense.
Which ones are overlapping? That's right. Those ones that x is less than minus 5. It means that the answers that we have for this inequality, there are two intervals. One of those intervals is this. The other interval is this.
Why don't we do the Cartesian plane like we did for the other one?
We do not need to just, plot it. We only need to solve the
Notice for
inequality.
Wait,
visualization.
what's the thing in between the 0 and the negative 12? What number is the red ball?
It's minus 1. Look at this. I showed two conditions. The initial conditions overlapped with the conditions from the inequality. Yes?
Hello, my friend Luca.
He's not my friend, he's my
Get up, bro.
Greater than minus 5.
I put everything already.
Are there new domains now?
So they are the conditions of the inequality. X greater than minus 5 then becomes this. Then the overlap is x between minus 5 and x between minus 1.
That's right. Thank you so much, Omid.
We are going to talk about that when we come back after the November break.
Thank you.
Thank you. Thank you. It's minus 5.